Here's some tips on graphing sine of x. I'm just gonna dot my 0, 0 because that's where I'm gonna start. I always dot my x-intercepts first, okay, my crossings, right? And I know it's gonna start at 0 and I know it's gonna go to 2 pi, right? Okay? If I have in my mind that I've got this kind of shape going on, then I guess what I know? I know that at pi I've got a crossing as well. Does that make sense? Okay? So I'm going to have, these are my 3 intercepts. Okay? And again, if I'm thinking about the shape of the graph, the 1 is going to be where? The peak.
Pi over 2.
Yeah, it's going to be right here. So in between here, at pi over 2, that's where my 1 is going to be. Right? Okay, so I'm going to dot this is going to be my max. Where's my min going to be?
3 pi over 2.
3 pi over 2. So that's going to be the 1 down here, right? And guys, that's all I dot out. I don't plot out the 6ths or the 4ths or any of those, actually. This, if you don't, this is where you do want to be careful that you don't sketch something that looks kind of stupid, right? I mean, you don't. It does have a curve to it. This does take some practice, okay? But you don't want to do this, right? I mean, you don't want something that looks like that. It's got a certain curvature to it. So do the best that you can, and then you're going to extend it on the other side as well. Actually, usually we would mark those, but I have negative 2 pi, right? And then pi. Again, those are going to be my crossings. In the negative direction, I'm going to be down here, right? And up here. So again, I actually could have done this as just one sketch. But there's 2 whole periods of sine. So Keenan, I have extended this also to the left, okay? All right? And then if I'm going to do cosine of x, again, I'm going to do 2 periods of that. At the y-axis, where am I with cosine of x?
1.
This is the roller coaster, right? So this one would start here. Another way to look at it is it's also going to end there. It's like a roller coaster. So I actually know that I've got a 1 at 0, which means I've also got a 1 at 2 pi. So I might as well dot that in as well, right? Where is it going to be at pi?
Negative 1.
Down here, right? Okay. And then my 2 intercepts are going to be at pi over 2 and 3 pi over 2. So you can see I'm going to have a drop going this way, and I might as well extend the whole thing this way, right? Negative 2 pi. You have to see how good you are at sketching, so you can sketch the whole thing, right? Okay. We should have something that looks like this, right? It's harder to sketch on the board. Let's see. Something along the lines of that. And there's my cosine, rough, very rough on the board. Okay. So, couple of terms here, right? We talked about this actually on Monday. Anybody remember what I referred to as the peaks, the height of the waves?
The amplitude?
That's the amplitude, right? Okay. We refer to this in shorthand as the absolute value of A because we're talking about a distance. So we use A for amplitude, that'll be. So actually, in the parent graph, the amplitude, absolute value of A, is always going to be what? 1. Amplitude is from the baseline. And by the way, if you take a physics class, it's going to be the same for light waves and sound waves, all kinds of waves. The same terminology is going to carry over. When we're talking about amplitude, we're talking about height from the baseline, okay? This is our baseline, because this is what the wave is rotating about, right? Okay, so we refer to that as our baseline. So the x-axis in this case is going to be the baseline, all right? Okay, so what is the period of sine? Yeah, it is simply, you notice that this wave is exactly the same as this wave, right? So we're just saying where is the unique portion of the graph where nothing is repeated, and it will be from 0 to 2 pi. So we would say the period of sine is 2 pi. Is it any different for cosine?
Nope.
It isn't. This here is exactly the same as this, okay? And of course cosine and sine can shift from each other, okay?